One of the powerful features of state trees, which is often overlooked or underused, is the ability to add conditions on whether a state can be entered or whether a transition can be triggered. And these conditions operate independently of the tasks and provide you with an extra layer of control. These conditions allow you to create more simpler, focused tasks and then add extra layers of conditions on top of them when required. At the moment, our door will transition from door closed to door open as long as a player is within a particular distance and looking at the door. However, if we wanted to add an extra condition that says that the open door can only be entered if the player has a particular key card or security level access, we could do that using conditions. And this means that we don't need to change the logic of our task. The way that our example will work is that when our player picks up a key card like this, the key card will add a tag to the player's tag container, and we will then access that tag in the state tree to add that as a condition that is required before the open door state can be entered. In the last video, we looked at evaluators, and we will use our evaluator that we created to get a reference to our third-person character on which the tag container exists. We can then use that in our enter conditions. To add an enter condition, simply click on your state and then go to the details and to the enter conditions here. And if you press on the plus, you can add a new enter condition. This gives you access to built-in conditions, which a state tree provides, and there are many of them. You can check tags, whether classes are equal, compare bools, floats, and so on. There is also an option to create your own conditions, which will show up in the menu here. And that's available from the new condition drop-down, where you can choose state tree condition blueprint base as your base class. What we are going to do is add a condition to our open door state. So a condition that determines whether this state can be entered. So we click on the state, we go to the enter conditions, and what we are going to do is compare whether our player character has picked up a key and therefore obtained a tag to state that he has the key card. So we can click on the plus, and we want to check whether our tag container has a particular tag. And there are also other options like checking tag queries or checking for multiple tags. In this one, we'll just do has tag. So we click on that, and now we need to find the tag container we want to compare. So we'll go to the drop down, go to our player evaluation, which is our evaluator, where we get access to our character reference, and from there we get our tag container. We can then compare the tag container to see if it contains a tag. And I've created some keycard tags for like level 1, level 2. We'll set this as level 1. And now this condition will be evaluated to determine whether we can enter the transition or not. You can also set whether it's an exact match or even invert it to say that it can only enter if it doesn't have a tag. And we can compile that and save it. So what should happen is our tree will go from the root to the door closed state. That will do this trigger transition task to check that we're looking at the door and within a particular distance, and then it will trigger a transition which will come to the open door. However, the open door requires an enter condition that our player has a key card with that tag. If it does, it will enter this state, but if it doesn't, what will happen is the state tree will then fail in its transition and it will return to the root because it has no other place to go to. From there, it will go back to the door closed. Now in 5.4, there is a bit of a bug which should be fixed in 5.6, and that is when we go back to the door closed and run this task again, this particular variable is not being reset to its default value of none. And that bug will be fixed in 5.6 from what I can see. But in this particular version, we will just have to set the current door gameplay tag to its default value when we enter the state again. Otherwise, we will get a strange error. But now if we play, when we go up to the door, we're in the right distance, we're looking at it, but it will not open because we do not have the key card. We go and pick up the key card and now go back to the door. Now we're in the right distance looking at it, we have the key card, it will open. And then as usual, it will close. And if we return, it will open again for us. So that means that the enter state condition is now controlling whether we can enter that state or not, in addition to the transition that was triggering it. You can add as many conditions as you like by pressing on the Add New Enter condition, and then decide whether they all have to be true or whether one of them can be true using Booleans. And creating your own condition is simply a matter of clicking on the new condition and choosing the built-in state tree condition blueprint base. You click on that, then go to your folder, and maybe on this condition we will make a check to make sure that our ship is not in a red alert status. In other words, its status is normal. So we could call this state tree condition status normal and click save. When we open up our state tree condition blueprint, you will find that it looks very similar to the other blueprints with tasks and evaluators. So in your class settings, you can give it a blueprint display name. So we could call this our not in red alert condition. We can give it a category. This could be ship status category, where we're checking conditions on the ship. In the class defaults, you can change the name that appears in the node. So this could be the ship status normal condition. And this will give a slightly different description in the state tree. Again, there's options to change the icon name and the color, but as I said, I think you need to drop down to C++ and Slate for that in the current versions. In terms of the override functions where you can execute your logic, the main one that we have access to is the receive test condition. And essentially, the return value determines whether or not the condition is met. So in our case, we only want to open the door if the ship status is normal. In other words, we are not in red alert. So we could get the red alert status as a Boolean. We can set that as an input, so we know that will be set by the tree. And then we want to only return true if red alert is false. So we can say not Boolean and put that in there. And that will determine whether the condition passes or not. And as you can see, you can make these conditions as complex as you like using blueprint code. If we go back to our state tree itself and we go to our open door, now in the enter conditions, we can add an extra condition. And we can go down the menu and see that under ship status, which was our category, we get the not in red alert condition. We click on that and it will show up with the description name ship status normal condition. It will automatically be an and, so both of them have to be true, but you can change that to an or, so only one or the other needs to be met. And there are options here to increment the depth of the expression, so you can have more complex Booleans being evaluated. And basically, we want our red alert status in to be bound to the player evaluation, that's our evaluator's red alert output. We compile, and everything should work as normal because our red alert status is obviously false. But just to check, when we go there, it doesn't open without the key card. We pick up the key card, and now it will open as both the key card condition is met and our ship status is not in red alert. The question is though, what happens if an enter condition fails? Because as you can see here, we've got enter conditions, but there is no way to define explicitly what happens when this condition fails. In our current setup, what will happen is the tree will fail to enter this state, and so its default behavior is to return to the root, and then it goes back to the door closed, which is fine in our case because the door remains closed. However, if this state was somewhere down here, would we want it to return all the way to the root? Or would we want to control where this failed condition next transitions to? And that's something that you have to consider when using conditions, or when considering what happens if a state cannot be transitioned to as expected. Otherwise, your tree will not behave as you expect it to. So for instance, perhaps I want a situation where if the player tries to access the door without the key, an alarm state is then triggered. But I want this failed condition to transition to that alarmed state. But as I said, there is no way of setting that in the enter conditions. So how do we actually do that? Well, let's say, for instance, we add a state which is called alarm if no access key. So we want this to fail and go to this state here when that happens. And when it goes to that state, we'll just give it a debug task to run, which will say no key access alarm. And we will put the reference actor as being our door. Now here, we have to somehow force that condition when it fails to go to the alarm if no access. In order to do that, we will need to change the structure of this open door state and then take advantage of the behavior rules of the state tree when it fails. The way we will do that is by creating a parent state for this open door. So we'll go to root, we'll say add state, and we'll call this try enter open door. We can then drag this up here, put that there, and then add this as a child to the try enter open door. We'll also add a fallback state to this parent state. So add another child state, and we'll call this failed to open door no keycard. So what should happen is that the door closed will now try to go to the try enter open door instead. So on state completed, we'll tell it to go to the try enter open door. And the try enter open door has a selection behavior of try select children in order. So the first state it will try to enter is the open door. And the open door has conditions that must be met. And the way that state trees work is that if this now fails, instead of going back to the root, it will go back to the last selected state that it managed to enter. And this will then try to select the next child it can enter, which should be this one, on which there will be no enter conditions. We can then put a transition on this state, and we can maybe just tell it to on tick to transition down to our alarm if no access key state. So if everything works as we expect, the door close will try to enter the enter open door. That will then try to enter the open door state, but this has a condition that must be met. And if we don't have a key card, it will select the last state that was active, which should be its parent. Its parent will then follow its selection behavior and try to select the next child in order. So this one failed. It should then go to the failed to open door no keycard. That should then go to the on tick, so straight away it will transition to alarm if no access key state. And this one, we've put a debug text on there, but we could also tell it to then transition back to the door closed. So we would then be able to pick up the key card and enter the door again. But let's just see if we get into this state. So now if we go and play, so if we try to enter without a key card, we get the no key access alarm state message being delivered, and we can't access. Even if we go and collect it now, it will not open the door as we are in a different state. So we need to transition back to the original state that we want to go to. Because we don't want to go back to the root, we want to go to the door closed. So on this state here, we could maybe just put a little delay in there, just for our... So on that delay, maybe we give it a 2-second delay, and then we will say on state completed for it to transition to door closed. And we can compile. So after 2 seconds, this will go back to door closed, and we should then get to have another go after picking up the key card. So if we now go and play, we go, we get the no key. 2 seconds later, it changes back to the normal door closed state. We pick up the key card, and this time it opens because we have the key card. So that's one way that you can control what happens when a condition fails, by providing a fallback state and by being aware of the fact that when it's in a group of states, type state, when this fails, instead of going back to the root, it will go to the last state that was selected properly, which will be the try enter. That will then jump over this one and choose the next one, which is the fallback state for us. You can also use the type of event that triggered the transition as one of the conditions. So for instance, when you go to your door closed, there is a required event to enter under conditions. And in transitions, there are multiple ways to trigger them. So we've just done on state completed, but as a trigger, there is also an option for tick and for on event. And you can take advantage of the event that is triggering the transition to act as a condition as well. So for instance, if we go to our try enter open door, on its enter conditions, we could say that it needs to have a required event to enter. So only if an event which has a particular tag, and let's say for instance door open is our tag, is triggering entry into this state, will it be able to enter. And on our door closed, we could add a different transition here. So let's add another transition, and this says when it receives the on event, and the required event will have the tag door open, it will transition to try enter open door. So this will get an event on it, and when this state receives this event, it will try to enter the try enter open door. But that has a condition that that event must have this tag. And the way that you trigger the event is if we go to our check player distance, we are using the finished task at the moment, but we can also use a send state tree event. And in the event, we can split that and we can give it a tag. But we first of all don't give it any tag. So what should happen is that when this state sends a state tree event, it will try to enter the open door. But if that event does not have this tag, this will fail and it will go back to the root, which will then go back to the door closed. And that will happen regardless of whether we have the key or not. So if I go and play, if I try to enter without the key, nothing should happen anyway. But now I pick up the key and I still cannot enter. The door will not open. And that is because we are not meeting this condition for the tag. Now, if I go back to the player check player task and I give it the correct tag, so send the state tree event with door open, we should get a similar behavior that we were getting previously. So first of all, if I try to go without the key, it will say no key, and we will go to the alarm state. I pick it up and now I go, it will enter both conditions because we have the tag and we have the key. So that is another way of adding conditions using events. And in future videos, we will look more in detail at transitions and sending state tree events. You can also require a payload structure, and I've done videos on payloads, and I will link to that in the top right. As I said at the start, you can also add conditions to transitions in order to decide whether that transition can go through or not. So if we go to our door closed, when you drop down on a transition, you can add a condition to it. And these conditions are very similar as the ones that we had on enter state. So you have the same options available and you can create your own. So we could add that same key card requirement as a condition for this transition to actually be activated. So we go to the condition, again, the tag container. We can go to our evaluator, character, get the tag. We can enter the tag that we need, which is keycard level 1. And when this event is triggered, it will only transition to the try enter open door if this condition is met. So we would still need to have the key. Similar to when we added conditions to the enter state, you do have to consider what happens if this condition fails. Again, you cannot specifically direct it what to do if it fails. But the way that you do it in a transition is you add a fallback transition. And the way that transitions work is if you have multiple transitions, they will try to follow the transitions in order. So this one at the top will have precedence over the one underneath. If this transition has a condition, and that condition is met, it will go through. However, if the event is triggered and the condition fails, we then need to tell it what to do. So we could add another transition, which is exactly the same on event. And we can give it the event that we want, which is the tag door open. But on this one, we don't give it a condition. We tell it to then transition back to door closed. So what will happen is if this transition event comes through and the condition is met, it will go to the try enter open door. On the other hand, if we send this event to the state tree, but we do not meet the condition of having the key card, it will then go back to the door closed, which is the same state. So the key thing when you add conditions to transitions is to always have a fallback transition that will be triggered if the transition with the condition fails. And the order in which you add your transitions determines their priority. And this should work just as we would expect. So again, without the key, we can never enter that state because the transition will never happen. When we pick up the key, we can enter that state because now we are meeting the conditions both in the transition and on the enter state. As you can see, conditions can be a useful extra layer that you can add to your state trees. You can also remove some of your tasks and just have conditions which are triggering transitions, particularly when you change the trigger to an on tick, which means that it will continuously try to transition to the next state when that condition is met. So I hope this explains how to use conditions and especially how to deal with failed conditions and what happens next, so that you can always predict what your state tree will do in any event.